Chiral.
Chiral.
Chiral. Stereoisomers.
Okay, so today we will present about stereochemistry. Okay, first we will continue with our first compound.
Okay, I will explain about the difference between chiral and chiral. Okay, about chiral. Chiral, its characteristic is non-superimposable, have chiral carbon, and doesn't have plane of symmetry. By mean it doesn't super non-impossible is, as an example, my hand. Okay, I get my right and left, and it doesn't super, is non-superimposable. Look. Okay. But chiral, the characteristic is doesn't have chiral carbon, superimposable, and have plane of symmetry. And for the example, a chair that we lean at the mirror, and it's fit well and have the same shape. Okay. Our first compound is 3-chloro-2-butano. It have 2 chiral carbon right here and right here. We use formula to the power of n, and n is the number of chiral carbon. Continue.
Okay, so this is our isomers. Okay, as you can see at the first compound, we have CH3, Cl, and H. So this is the mirror image. So as you can see, the mirror image is different. So if we put them together, they will not be superimposable. So we have conduct the molecule for this structure. So as you can see, the molecule for the structure is mirror image to each other. So if we stack them together, they will not be together because it is chiral.
Okay, so for the next stereoisomer is this for compound 3 and compound 4. So we can see here it's called enantiomers because it is non-superimposable. So for the compound, I will show it for you. Okay, this is OH atom and this is Cl atom. You can see that for compound 3 and compound 4, like different. Okay, sorry. Okay.
So as you can see, compound 1, 2, 3, and 4, this is diastereomer. That means they are not mirror image to each other, so that you can differentiate them. Okay, so we will move to the next compound.
Our next example is butane 2,3-diol. This is the formula of butane 2,3-diol. As you can see from here, we can already determine that the compound have 2 chiral carbon. We don't even have to draw the structure, and we can determine it just from looking at the formula. Like you can see, this C is bonded to different types of atom, and when we have 2 chiral carbon, we can determine the number of stereoisomers for the compound. So here we have 2 chiral carbon by using the formula 2 to the power of n, which n represents the number of chiral carbon. We can see that the formula will be 2 to the power of 2. So we have 4 stereoisomers.
Okay, this is butan 2,3-diol. So we can represent the compound by using Fisher projection. To draw Fisher projection, for this compound we have 2 chiral carbon. So the one chiral carbon represent the intersection between the vertical and horizontal line. So at the vertical line we put the most highly oxidized carbon atom at the top of the vertical line. So if the structure are like this, it has no plane of symmetry. So we have 2 isomers. Compound 1 and compound 2. Isomers 1 and isomer 2. The relationship between this compound is enantiomers. So enantiomers, the characteristic is they have same physical properties, which is same boiling point and melting point. Okay, this is we have construct the 3D structure for enantiomers of butan 2,3-diol.
Now, for the last isomers, for putting to the compound, you can see this is the isomer. So, when we construct the Fisher diagram and produce the mirror image for the compound, you can see that it is the same. You see, the same. So, what is this meso compound actually? What is the cousin of this meso compound? So, meso compound, meso compound is a chiral carbon. Yes, that is true. But what is so fascinating about it is a line of symmetry. Wow! Yes, that is true. So, meso compound, in short, is compound which has chiral carbon and which has line of symmetry. So here you can see the compound. So now this is 1/2 of the compound. And this is 1/2 of the compound. So you can see it is actually the same. No such difference exists. So meso compound, in short, is chiral carbon compound with chiral carbon and so to have a better understanding for this compound, let's say we have 2 kind of shapes, and the kind of shapes that we have is very different, although it's a shape. So to make sense of it, meso compound is the same in formula, is the same in the compound, but different in the spatial arrangement. So what about the facts? So compound, which is meso compound, is different from others. It's called diastereomers between the other molecules, between the other isomers, between this and this we already know is enantiomers. But between this and these 2 compounds, this is called diastereomers. And the boiling point of these 2 compounds is the same, but the boiling point of this compound is slightly different. But we don't know is it higher or lower, then we need to go to the lab.
Okay. 1, 2, 3.
You can count
down, see like 1, 2, see is chiral C. Yeah.
Thank you.